Hello everyone, welcome back to this channel. So this is the last part of the ENA-X setup walkthrough that I want to show you. So if you remember from the previous video, we talked about the noise figure measurements, the GCA, gain compression measurements, and also the spectral analyzer measurements. So those are individual setup. In this video, I'm going to show you how you can combine all this into one view, and from there you can just plug in your device on the test. For my case, is an amplifier. Calibrate one time and you are good to go to run all the measurements at one go. I will start with S parameter measurements. So let's do multiple traces, 2, 3, 4, display, and let's say we want to do this. Okay, this is up here. No, let's do this. S11. Let's do this. Right. So that's one way of doing it. Let's do this S21, S12, and S22. So for S11, we want to change the format to Smith chart. S22, the same format to Smith chart. And then I want to do this. Maybe I drag this over here. Windows 3, let's turn that off. And this one, change it to here. No, this one to here. Windows 5, let's turn that off. So this is the S parameter. Let's turn on the marker. So it's all coupled. Let's go to the next window. Window 1 that we highlighted, and I want to do a new channel. Channel 2, which is here. And channel 2, I want to set it to gain compressions. So let's do from 1 gig to 4 gig. Smart power, like what we did just now, from -15 to +8. It's a bit overstretched, but it's a good start. And part 2 internal path compression 1 dB, apply. Okay. So the only thing that I didn't change here is the frequency 1 gigahertz to 4 gigahertz. One thing to be aware of, in between channels, it doesn't mean that your frequency start should be the same. When you calibrate, it's still be able to calibrate individually different channel. So for my case, I just want to make life easier. So let's add in another trace, 2, 3, one more, and trace 6 I want it to be the com in, trace 7 I want to come out, trace 8 is a delta gain. Yep, and then I turn on the marker right in the middle. So this is not coupled, if you see that. So my channel, 2 different channels, 2.5 gig. And let's say my channel, so let's change that to so everything is in the middle. So I want to create another channel. Let's turn on the display first. The 5. This is my noise figure. Yep. So noise figure the same, 1 gigahertz and 4 gigahertz. I have bandwidth log shape correct. And that power level is about 10. Can change that. Noise figure format is a good start. Let's say high. Yep. Average on, let's say 200. Apply. Okay. So noise figure, we'll add a couple more traces. So noise figure here, I want to change it to S21. And I'll turn on the marker 2.5. Yes. So let's turn on the last one, last channel for display 7, channel 4, which is this one. So I want it to be a spectral analyzer. with input signal sweeping 1.1 to 1.6. So start stop 4 gigahertz, stop 1 gigahertz. That's the frequency range. Source into CW. I want it to be linear frequency 1.1 gig to 1.6 gig. Okay, then power, we set it to minus something low, so minus 18, and on apply. So as you can see, it's actually running through different channels. Well, the obvious one will be this spectral analyzer. So let's say we are happy with this setup. It's a bit of mess, but you get the idea that we're trying to do here. So let's say I move it to here, and this has, oops, let's throw this thing here, then S22 we'll move it to here. So this 4 is the S parameter, this spectral analyzer, this noise figure, and this is the gain compression. Let's run cal. Smart cal, so this GSC, sorry, other cal, cal all. It will just run through all the calibration needed for different mode. And once you click next, so this is the summary of what's going on. Power set, don't really know, don't really need that. Female to female. And next, so you can see that different points, different channels. So you can actually change some of the channels to different points, but I didn't change mine, so as it is. So connect power sensor to port 1. So connected, measure. Oh yeah, again I have to change the power level to minus 80 instead of 0. Let's try again. Next, it's minus 18, minus 18, and minus 18. So we measure. Right, then we connect port 1 to the eCal, measure, to eCal, adapter, port 1, port 2, so it's done, finish. So get pretty much good reading for most of it. Right, let's put back the amplifier. So this is too saturated. Right, looks pretty much the same as we tested individually. So that's it. This is the setup, so you can combine multiple measurements in different channels and then put all on the screen, and just one calibration steps which cover every different setup, and then you can just plug in your device on the task and do the measurements at one go. So I hope this helped. Thanks for watching.